The problems in set could be divided basically into two. For the sake of our level, we have 2 set problem and 3 set problems. 2 sets problems and 3 sets problem. 2 set problem is simply a problem or a set problem that contains just 2 subsets, while 3 set problems on the other hand contains 3 subsets. Okay, so just as we are solving more problems, you will see a case where we have 2 and 3 set problems. So let's just go straight to the question, the first question we have. The first question is, given that mu is equal to the even numbers between 0 and 30, the first thing we have to do is to list the element in mu. And the element in mu is equal to the even numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30 inclusive. Okay, then we have the multiples of 6 between 0 and 30 as the elements in set P. So the multiples of 6, we have 6, 12, 18, 24, and 30 inclusive. Then we have the set Q to be equal to the multiples of 4. 4, 8, 12, 16, 20, 24, then we have 28. And the question is, find P union Q. Of course, P union Q is the combination of the elements in P and Q. The elements in P and Q. Now, if you look closely, P union Q will be equal to 4. Will start from the least to the highest. So we have 4, 6, 8, 12, 16, 20, 24, and 30 inclusive as P union Q. And looking at it, there of course is no answer. Most times JAMB give you this kind of problem just to see how best you understand the concept, okay? But there's no answer here, and there's nothing we can do about it. But let us use this same problem to consider P intersection Q. So P intersection Q is, of course, the elements that are common to both P and Q. And if you check that, you as well realize that 12 is here, 12 is here also, and 24 is here, 24 is here as well. Is there any other element common to both P and Q? Of course not. So we have that P intersection Q, which is the list of elements that are common to both sets P and Q, will give us 12 and 24. So let's go to the second question. We said we're given this problem. If P equals 1, 2, 3, 4, and 5, and P union Q equals 1, 2, 3, 4, 5, 6, and 7, we are asked to find the elements in Q alone. The element in Q is seen as the elements that will complete the universal set. Universal set in this case is P union Q when related to set P. Don't worry, let me simplify it further for you. We have P to be equal to 1, 2, 3, 4, and 5. We have P union Q. It's just like saying A is equal to 5, B is equal to 10. Find B minus A. That's just what we're trying to say. Okay, so this is by the way. So we are asked to find the elements in P union Q that would complete element Q or the set Q to give P union Q back. And which are, of course, Q will give us 6 and 7, such that P union Q, if I combine the elements in P and the element in Q together, I will have the same thing as the P union Q that were given in the question, which is 1, 2, 3, 4, 5, 6, and 7. So my correct answer is 6 and 7. Okay, before we run out of time, let us consider this. We have, in a class of 46 students, 22 play football, 26 plays volleyball. If 3 students play both games, how many students play neither of the game? This particular problem is a two-set problem, because the subsets are just 2. We have volleyball and football. So how do we go about this? The first thing is you can decide to draw a Venn diagram or just use the formula method directly. How do we do it? The universal set, let us denote volleyball to be V and football to be F. So the number of people that play volleyball gave us N of V to be equal to 26, and N of F is equal to 22. So they said the number of students that play both games could be seen as the intersection of volleyball and football. So we have number of V intersection F will give us 3. We now asked to find the number of students, that play neither. That is, number of students that do not even play any of volleyball or football. They might play other games, okay, such as Scrabble and the rest. Okay, so we have to use the formula method. And how do we go about it? It says the union of a particular set, in this case V union F, minus students that play neither of the game is equal to the number of volleyball plus the number of football, then minus the number of volleyball intersection football. If you substitute these values, we will have that our universal set, which is the combination of set V and F, is 46 minus Y, which is equal to 26 plus 22 minus 3. So if you add the 2 together and subtract 3, will give us 46 minus Y. 48 minus 3, of course, is equal, let me erase this so that we have enough space. So 48 minus 3, this gives us 45, then 46 minus Y. If I want to make Y stand alone, I'll take Y to the other side of this equation, then bring 45 over here. And if I do that, I would have my answer to be 46 minus 45 equals y. Therefore, y is equal to 1. So, one student did not play any of the games listed above. With this, we have come to the end of the class. In our next class, we'll solve more problems on set problem. So we will see in our next class.